Hello, hello. Okay, I think we get started. So my name is Nadir, and um, I'm happy to host a session about Tetris event. And where I'm located, it's very early in the morning, so I'm gonna keep my voice low. But please let me know in the chats that if you cannot hear me well. Um, hello. Just leave a comment in the chat, please, if you can hear me well and see me well, so I can proceed with the session. Great. Okay, great. Yeah. So today in today's session, we're gonna try to build a Tetris game using Java. So before we started, like actually building the game, first I think we need to understand the concepts behind it. Um, so so first I wanted to share some like background on how the Tetris game is played and um, what are its building blocks. As you know, Tetris has building blocks, and they come in various shapes and sizes. Uh, so um, First, I wanted to refer you to a Wikipedia page. So let me share my screen on Wikipedia so we can see what the definition looks like for Tetris. So as you can see here on the Wikipedia page, so Tetris blocks are called tetrominos, and they usually have like 7 unique shapes. So one of the shapes is called uh, straight line, as you remember from playing Tetris game. If you haven't seen Tetris game before, please comment so I can stop and explain how it's played. Let me know if you haven't heard Tetris before. Has everyone played Tetris before? Just leave your comments, please. I assume everyone has played it, but uh, if you haven't seen this game before, there are many various sources, so we can actually like look it up in our spare time. But for today's session, so we try to come up with a game that looks like this on your screen. So there are building blocks dropping from the top, and those building blocks are in various shapes. So as you see, there are straight shape that resemble this block, and a square shape, and T shape, and L shape, and S and Z type of shapes. It lists 6 of these shapes, but we're gonna build 7 because there's a symmetry Z, S, and C, right? And we're gonna introduce L shape as well as J shape, which is inverted of L shape. Okay. So I have a project here set up already. Let me share that project screen with you. Okay. So it's gonna be trial and error. So I'm gonna build it together. I may make mistakes along the way, so please bear with me. Okay, let me share my project screen. Okay. So this is an IntelliJ project where we try to build the Tetris game. So Tetris game has various components. So before I start, so I wanted to say that we're going to use Java Swing framework. So this framework helps us build user interface on the screen. So whenever we start our game, we see a nice user interface, and we can actually interact with the GUI. So swing we use to draw GUI elements like button, a text box, and also swing allows with us interacting with the GUI. So when we click a button, we interact with it. So some event happens. For example, button clicked event, and based on that, we can actually take some action. So it handles actions as well. So we're gonna also use Java timer component, so that allows us creating a game cycle, because every time we start the game, it keeps looping until we actually close the window. So we can build, we can actually interact with the window and close it. Until then, game keeps playing. Okay. So I'm checking my projects to make sure that we are on track. So first order of business is that we're gonna build those shapes. So those shapes, as I said, there are 7 in total, and those shapes to build those shapes, we're gonna use Java enum. So Java enum allows us to define objects which which will have certain behavior, and those objects will have only limited number of values. So let me start by creating enum here. So we start with Java class, and as you can see, we create enum. So we choose enum here. Okay. And as you see, we created enum here, and then we need to define the values this enum is gonna take. So those values will be the one that we define. So enum will have different fields. So as you probably remember in Java, so enum is same as class, but it can take certain limited number of values. Correct me if I'm wrong in my definition. Feel free to comment in the chat. But let's start with what fields this enum will have. So this enum will have it will store the shapes that Tetris elements will use. So we're gonna use something called coordinates. So those coordinates define the shape of each of tetrominos. So I'm gonna start with coordinates. So as you know, coordinates in 2D plane, they have x axis and y axis. So that's why we define two-dimensional array to store actually values in x and y axis. Okay, so we create two-dimensional array, and we call this coordinates. Yeah. So it complains that it's not initialized. That's fine. We're gonna initialize it. And okay, let me check the chats to make sure. Do you have any pre-written code, or is anything going to be done from scratch? So I have pre-written code, so I'm following that pre-written code. But so if we cannot cover the whole project within next hour and a half, for example, then I'm just gonna use my project as a backup, so we can actually start from my project and see the final result. But let's see how far we can go. I use one of our users say I used to play this in the Game Boy. Yeah, I had this device also when I was younger, and I remember from those games. Actually, Game Boy came with other games as well, not only Tetris. Yeah. Okay. Yeah. There are many different implementations of Tetris. I'm sure if you search online, you will find. So I've been doing some research, and I found that there's actually easier implementation using Java Swing, and so I'm gonna follow that approach as we progress, and I'm gonna give you some reference at the end of the session, where I actually sourced this method. So for now, we're gonna start from scratch and see how far we go. Okay. Okay. So we have coordinates, and those Tetris blocks, they also have uh, uh, colors. So we want to see color. We want to see those blocks to be colored, and so to contain the color, so we're gonna introduce the color component. So Java Swing has color built. It provides us color class. So, and we can use this class in our project. And so when we create the elements, Tetris elements, so we want to supply coordinates and color for each of these 7 elements, right? So as we as we have seen in the beginning, we're gonna have 7 elements, and those elements will have coordinates and colors. Okay. So I'm gonna write a constructor. So we're gonna pass coordinates. Okay. And color. And so when we actually create enum values, so we pass these two arguments to build enum elements. So I'm gonna assign coordinates and color. Color C. Okay. And now complaints. Okay. And here I can define. Let's start defining our shapes. So the most prominent shape probably is called like square shape. So square shape has like 4 squares, all made up, and they form a square. So as you see as you remember from the Tetris game, and so that would look like something like this, right? This is a square shape, right? And for line shape, we have this kind of shape. This is for line, and for Z shape, for example, gonna have something like this. So just to have a visual understanding, so we're gonna build each of these elements. So as you see, there are each of these Tetris elements, they have 4 blocks, right? 1, 2, 3, and 4. Same with line shape, right? 1, 2, 3, 4, and same with the Z shape. Or if you see T shape, right? It also has 4 elements. 1, 2, 3, 4. So that tells us that when we define the coordinates, each of these blocks are defined as a coordinate. So we're going to define 4 coordinates, okay, for each of these blocks. So we're going to have 4 coordinates and then color for each. And we want to color it because when we actually build the game, we don't want this to be mixed up with each other, and we want to see some level of separation, that this block actually is different from this block color-wise, okay? So that's why we use different colors for it. So let me check the comments. Can you increase the font size a bit? Yes, I can. Thanks for your comments. I will. Okay. So I increased it. Hopefully now it's more visible. I joined a little bit late. No, it's not too late. It's just right in time. We're just getting started. Actually, there are various ways to build the game, so we are just adopting one of the ways. You haven't missed anything. Okay, yeah. So if you want to help me out along the way, please leave a comment. So I know that I'm on the right track. So I'm okay. So let's build this square shape, right? So when we build the enum in Java, so we're gonna define the enum like this, but we don't want to leave enum hanging like that. Let me comment these first. Right? So when we define an enum, we also want to define two arguments, because in our in our project, we said enums will contain these values, these arguments, right? So we're gonna define this square shape. So we're gonna pass the coordinates. Okay, then we're gonna pass two-dimensional array here, and coordinates we're gonna use integer value. We don't want to use double precision floating points numbers for it. We just use integer numbers to make things simple. And so when we pass two-dimensional array, we have an option to define the array values right in here. So for square shape, I'm going to define values 0, 0 for as you said, as you see, we have 4 sub-elements for this square shape, right? So we need to define coordinates for each of these. So I define it for one of them. It's 0, 0. And so 0, 0 means we are in the middle of the coordinate, okay? And the first element the first value is x value, the second is for y. So if you take, if you think about coordinate plane, and there are axes, right? So for we define we pick 0 in the x-axis and 0 in the y-axis. So we're exactly looking at the center of the coordinate plane here. Okay, this is where the square shape starts. One of these, the sub-elements start, and we define the other one. So we can define it 1, 0. So now we're using 1 from x coordinate, x-axis, and 0 from y, and we define the remaining 2 in the similar way, 0, 1, for example, and so we have 0, 0, 1, 0, and we have 0, 1, and we're gonna have 1, 1. So that defines the coordinates for each of these elements, right? 1, 2, 3, 4. So we define it 1, 2, 3, 4. And now we also need to define color for it, for the square shape. For color, as you see, we can define RGB. We can set an RGB color. So we can choose to define RGB independently by giving 3 different values. Okay. Let's say we have 202 in color, 100, and 202. So it means some color in RGB. So if we see what this color means, let me check how it looks like. 2 RGB. Define. Okay, so we have 200, 100, 200. Okay. Yeah, it gives some kind of color. So as you can see in my editor, that this specific color is a result to this color, right? So that's like easy to imagine what this color means. So let me check if this is yeah, imports, action, events. Yeah. Yeah, for now, we don't need graphics for now. We can just focus on elements. In the second section, we're gonna use yeah, key events. Yep. So we need key events because when we actually control the shape, so we need Java Swing to capture the key events and actually react to that. So when we, for example, press the arrow buttons, right, from our keyboard, we want to actually to be able to move the elements from to the left or to the right, also rotate the elements. So this is important so that we can actually place the elements in the correct place in the Tetris plane. Okay. Yeah. So for now, we're not going to use these import statements. We just need color for now. So yeah, and we're gonna define the remaining 6 elements. So we will have Z shape, for example, that we have seen here, this one. In the same way, we define past 2-dimensional arrays. And here again, we pass we pass again those 4 different values. Okay, let me just copy from here and paste. So the coordinates will be different. So for this one, I'm gonna use 0 with -1. We define again 4 pieces, right? We have 4. The Z shape is composed of 4 blocks, right? So I'm gonna define 4 coordinates again. So here we have 0, 0, and -1, 0, and it will be -1, 1. So it's 0, 0, yeah. And we have also color. So for color, we can define something like, let's say, 200, 100, and 0, right? Okay, it doesn't like our definition. We're missing something here. Shape, yeah. I should actually put comma here. So yeah, so we define 2 of our shapes. And let's define the remaining one to speed up the game development. Okay, we have 1, 2, 3, 4, 5, 6, 7. Okay, so we're gonna have S shape, and we're gonna have line shape like this one we have seen, and we're gonna have T shape. And what else we're missing? We're gonna have J shape, the invert of this L shape. Okay, and have square shape, Z shape, S shape, line shape, square shape, L. Okay, we haven't defined L shape then. Yeah, this one. So we're gonna have 1, 2, 3, 4, 5, 6, 7, all 7. And let me define the coordinates. So we define it for Z shape, and for S shape, we have 0, -1, and 0, 0. We'll have 1, 0, and 1, 1. And for S shape, we use color, let's say 100, maybe 200, and 300. Yep. So we define we set up the shapes here, and for line shape, I'm gonna have 0, -1, 0, 0, 0, 1, and 0, 2. Okay. And for color, probably let's say 100, 200. Yeah. So all these colors are different. Let me check my comments to see. Could you explain what Z shape is for again? So Z shape is needed because so when we play the Tetris game, so one of the shapes are in the form of Z shape. So if we go back to the Tetrominos page, let me share that page with you. I'm gonna share the screen on Tetrominos. So as you see on my screen, so Tetris shapes, they take various forms, 7 of them, right? Line, square, and they also come with J, L, S, and Z type of shapes. So I'm referring to these shapes, right? So as you see, Z shape defines this shape. S is similar to S, right? And L similar to L. That's why we are using English alphabet letters to actually help us understand. So this is the O shape, the square shape, and the line shape. Okay. And we have another comment. Can you please explain how and why we're putting in particular order? So if we use, please explain coordinates for square shape. So for coordinates, we need to define coordinates for each of these blocks, right? So we use these coordinates to actually control them in the Tetris plane. We haven't created the Tetris plane yet, but those coordinates help with so they help with how we define where do we actually put this shape in the Tetris board. Okay, so those coordinates are important. So that's why coordinates actually give like structure to each of these Tetris shapes. That's why we define it 4 types of coordinates, because each of the Tetris shapes they define each of these coordinates. They define the Tetris shape, right? And why in this particular order? Because if you draw coordinate plane, right? So we want to go in order, right? So we want to start with 0, 0, and for example, in the case of square shape, so we want to start with 0, 0, um, and define the next one. Actually, we don't have to like follow this exact. We don't have to follow this exact order, so we can actually change, like put in various orders. It can be 1, 0, 0, 0, 0, 1, for example. It doesn't have to follow this order. So I hope I was able to explain it. Okay. Please explain coordinates for square shape. Yeah, for square shape, so we have four of them, right? So the order doesn't have to be in that way. We can use. We're just focusing on the center of the coordinates. Okay, coordinate plane. We don't want to go like way beyond of the center of the coordinate plane. That's why we're focusing on these values 0, 1, maybe 2, depending if we rotate the shape or not. So let me go back to the code. Okay. So again, so now we defined all of our shapes. So we are done with part of it, and to actually build the shape, we need to be able to like rotate the shape, and to play the Tetris game. So we need to be able to rotate the shape. We need to be able to, for example, give a random, which like choose a random shape when we start the game. So we need to define those behaviors. So let's open our project and create a new class. So what we created so far is tetrominos building blocks, right? And to actually use these blocks, we need to create a separate a class that uses this enum. So I'm gonna call it shape, okay? And so this class will contain let me increase the font size. So this class will use the enum that we have just created. Create terminals. It's a default package. Tetramino. Call it just Tetramino, and also this shape that we're creating will have its own coordinates. Private final. So again, I'm gonna use two-dimensional arrays here. So we are creating separate coordinates for shape, Why? Because when we rotate the shape, this particular shape can have different coordinates when we rotate, because part of the game is require us to rotate the shapes, so we land the elements in the correct in correct like a incorrect form, right? So we don't want it upside down, for example. So we want to land it in a correct form to the floor of the Tetris board, right? So we can like get rid of a line whenever the line is filled. So for that, we need to maintain separate coordinates for each shape. So let me create a constructor. And coordinates. So we're gonna set again like two-dimensional arrays. We create with int. So here we need to, we're gonna have four rows in the two-dimensional array and two columns. So exact same data will be stored here. These coordinates will change. That's why when we rotate, right? So that's why we are creating separate coordinates just for this shape. But coordinates from tetrominos that we had before, right? Those remain constant. They never change. That's why we're having separate coordinates here just for the shape. And yeah, and so so now shape, we need to define a method that actually assigns shapes coordinates to tetrominos coordinates to shapes coordinates. So we can create a separate method for it. Let's say private void assign coordinates. Right. So when we want to assign the coordinates, we want to receive just tetromino as one of the as one of the arguments, and we want those arguments and extract coordinates from this tetromino and assign to coordinates of the shape. So we initialize the shape with coordinates of tetromino in the beginning, but as we rotate the shape, those coordinates will change, obviously. That's why we need to copy initial coordinates from tetromino. So to copy coordinates from two-dimensional arrays, so we can use a nested loop. Okay, so we can create, first we iterate through the rows. We have 4 rows, and we're gonna loop as we increase. We're gonna increase the variable as we loop through the coordinates of the tetromino, and we're gonna loop through So we're looping through row first, and for each row, we loop through the column. And two columns, as you remember, X and Y, right? So that's why we have two. And we increase the and then we increase the J variable here as well. And so for coordinates, this coordinates. So every time we loop through, we want to copy the coordinates of shapes from tetromino coordinates to shapes coordinates. Tetromino coordinates. We can access its coordinates element, right? We just copy. Yeah. So this is how we copy. So once we copy its coordinates, then we can and then we can we can just focus on shape because we want just to we want to start with tetrominos whenever we create this shape, right? So we also want to maintain information about tetromino, this tetromino, okay. So what do we do with this? So we assign coordinates, obviously, when we create the shape for the first time. So here we just pass so we just pass the we just pass the we just call the assigned coordinates here. So now we need to define like what shape we're gonna start with. So let's say we start with tetrominos, pass, let's say with T shape, right? So as an example, we just start with T shape. Yeah. And we can obviously start define fields about rotation, and we can also start with random shape. So when we start the game, we want this Tetris game to start with a random shape. So we can define these behaviors. So rotation of element can be clockwise, okay, or it can be counterclockwise. So we're going to define these methods to make sure that we can actually rotate our shape as we play the game. So I see it's already 55 minutes past. We've been here for almost an hour. So I suggest we take a break, a 5-minute break, and then we come back and and just before we leave for 5 minutes, just I'm gonna answer one of the questions here. Is that shapes are predefined in Java? No, those shapes are defined in tetrominos enum. So as you see, we have tetrominos enum here. So we define shapes here, and they have different colors. So let's say we haven't updated the color here. Sorry, we can't have 300. 200, 150, and for example, 100 or 50, maybe 90. Different color. Yeah, we need to define these shapes separately as an enum, and we're using these enums in our shapes class. Yeah. So yeah, let's catch up in 5 minutes. Take a break, drink some water, maybe. I will resume the session in 5 minutes, okay? And hopefully we should be able to at least draw a board and also like see if we can like actually do some play on this Tetris. If we cannot, I have ready code, so we can start from the ready code and see how it plays. Okay. Yeah, I'll see you in 5 minutes. Hello, everyone. Uh, I hope that was enough break time. Yeah. Uh, okay. Just if everyone is here, let's resume. Uh, yeah, we have a new user. I think that person is asking. They missed part of the session. Can someone please update me on what was done? Yeah, we're moving very slowly, so I want to make sure that we have the foundations laid out solid, uh, and I don't want to spend too much time on Swing framework or how Java, for example, draws uh, shapes on a page, on a window. So that is less important. But what is more important is those building blocks of the uh, Tetris game. Okay, so that's why we're going uh, step by step to build the Tetris from ground up. Um, so far we created uh, tetrominos enums. So those enums they are used for um, so they are used for um, to build the shapes that we all are familiar with, um, and so as you see, those shapes come in different uh, in different like size. So this is like rectangle shape, line, Z shape, and T shape, right? So we define it enums here, and we also use those enums to actually create the actual shape for the Tetris. So when we rotate this shape, we want this to have different coordinates. That's why we are maintaining a separate coordinates variable here. So just let me check if everyone is here, we can get started. So I will resume where I stopped. So before actually resuming, so I wanted to also define one additional shape here. So the order here matters for the enums. So when we, for example, create a random shape out of these enums, we also want to create a shape which doesn't exist, which means it's like a no shape. It doesn't have a color, and it doesn't have like a proper defined coordinates. So I'm gonna call it dummy shape. Okay, so I'm gonna say I'm gonna use the same format here. Dummy shape. Instead, it will have 0 coordinates, and it will have black as a color. Yeah, it means like dummy shape, a shape which doesn't exist. We need this because when we initialize the shape, we initialize our shape, we're gonna use it. to actually define its coordinates. So we don't want to initialize with t-shape because t-shape already has some certain coordinates, but we want to initialize with dummy shape. So dummy shape has 0, 0 coordinates across the board, as you see, and then this we use as a starting point for our shape class. Okay. So we assign the coordinates, and we assign the coordinates, and the next part. So we want to define some random shape. So when we use the shape class, we want this to be initialized with a random shape. Okay. So when we start the Tetris game, because we don't know what shape it starts with, right? It starts falling from the top. Yeah, we can go like a line by line sequentially in enum, right? Telling that okay, start with square shape and then go to Z shape and S shape and then line shape. But if we follow this approach, the game would be predictable, right? So we don't want that predictability. We want game to be unpredictable. That's why we randomize the shape. So we don't know what shape will be falling next, right? So for this reason, we're gonna implement the random shape here. So to implement the random shape, we need to use Java's built-in library for random numbers, right? So here can use random number generator in Java. And random. So random it says creates the random number generator. So you can see the definition of this class, what it does. And so when we create the random number, so we use this random number generator to create the random number. So we need this random number because we need actually we need to pick a random tetromino and then assign this to the shape. So instead of creating in the class level, so what I'm gonna do is I'm gonna create a special method called get random shape. Okay, I'm gonna place my code inside the method. So now we can call random next int, right? So what next int does is so it returns the next pseudo-random next integer, and so the range of integer, as you know, so it returns signed integer, right? So signed integer has a range, right? So if we think about integer as 32-bit integer in Java, the first bit we allocate for sign, right? If it's positive or negative number, and the rest 32 bits we allocate for integer. So that means when we actually create an integer, we get really big number, right? And that number could be positive or negative. Okay, let me check the why 0, coordinates. There's a question in the chat asking why it's 0, coordinates. It's 0, coordinates because we want to define a shape which it's a dummy shape, right? So we want to initialize shape with that 0, coordinates. We haven't defined it. We haven't assigned tetromino to our shape yet. That's why we are initializing it with a dummy shape. That's why we use 0, across the board. As you remember, each tetromino has 4. Okay, sorry, my Siri is activated for some reason. Okay, I unintentionally activated my Siri. Sorry about that. So yeah, 0. That's why we use 0, just for dummy shape. So let's go back to the code and define actually. So we're getting a random integer, right? So when we get random integer, as we said, it will be in either positive or negative. So what we want is we want to get positive number and then use that number to randomly choose one of the tetrominos from here, okay? So as you know from Java, probably the enum, they have the order, right? So the order is important. So the one we first define it at the top has 0 as an order number, and this one will have 1, this one 2, and all the way this one have 6, 7, sorry. All right, so this is Java feature. This is order, like a number that each of these enums hold. So we're gonna make use of this order number. So when so we want to choose a random number out of this order, right? From 0 to 7. So we get the random number, then we get the absolute value out of it. So we have built-in method in Java, which gets the absolute value of this randomized number. If it's negative, it turns it to positive. If it's positive, it just returns positive. Okay. And as you may know, that the number that we generate can be any like big number out of that within the integer range. What we want is that number to be one of the numbers between 0 and 7. Okay. So what we do, how can we do this best? And one way to do it, one way to reduce this big number into any number from 0 to 7 is to use mod, right? From discrete math classes, if we remember. So we get 0. So we get 8, and it returns any number from 0 to 7. Okay. And now we have a problem. We don't want this shape to be initialized with number from 0, because for 0, as you know, we have dummy shape. We don't want random. We don't want Tetris game to start falling us the dummy shape. We want Tetris game to give us any of these square shapes except the dummy shape. So we need to exclude dummy shape from our random number. So what we're gonna do is we just, instead of 8, we use 7. So that means we reduce randomized number from 0 to 6, right? But if we add 1, we shift, meaning that now random number we get would be between 1 and 7. It was from 0 to 6 before, and we add 1, now it becomes from 1 to 7. Okay, so that's exactly what we want, from anything from 1 to 7, right? From 1 to 7, excluding 0. So we don't get 0 when we randomly generate number. So 1 to 7. Yeah, there are a little bit of discrete math going on. Hopefully it's a piece of cake for everyone, because we have it's very basic thing in discrete math. So and we need to pick one of the tetrominos from the enum, right? So so as you know from Java, when we call enum, it has built, we can call values method from enum, right? So values returns what? So it returns an array containing the constants of this enum. So it returns all the values which tetrominos contains here. Okay. So that's what we want. We want all these tetrominos to be returned to us when we call these values. Okay, and so those values, it returns an array of tetrominos. So we call just values. So values hold all the array. It holds all the values of tetrominos. And now, since we have a random number already here, so when we when we create random a random shape, so we call assign coordinates, and we can give values, pass values array, and for index, so we can pass this random number as an index. Okay. So again, random number here ranges from 1 to 7, right? And array we already have here, it has index from 0 to 7. Okay, because why 7? Because as you see, we have 7 elements and additional dummy shape, so we have 8 elements. So it returns 8 digits ranging from 0 to 7. But as we said, we don't want 0 because it's dummy shape. We exclude it here. So random number actually has any value from 1 to 7, and we pass any value from 1 to 7 here, and then in return we get any tetromino from here, from this range. Okay. So this is how we get the random shape when we start the game, and then we also want to define rotation. So rotation, we need to define rotation clockwise or counterclockwise. So again, when we define the rotation, we want to rotate the shape. We don't want to touch the tetromino, but we want to rotate the shape itself. Shape already has its coordinates. So we define a method to rotate. So when we rotate the shape, we want to get back different shape. So we, as a returning value, we so we're gonna get back the shape, but with different coordinates. Okay. So first we check if this shape is a square shape, because some of the shapes are rotatable. It makes sense to rotate, but some of them it doesn't make sense to rotate, right? So if we look at a shape which has a square, right? There is no meaning to rotate the square. So what we do is we check if this tetromino that we assigned is a square already. Tetromino dot square shape, square. Okay, so if it's square shape, there is no point to rotate. So we just return the existing shape. We don't want to play with coordinates. But if it's if it's not a square shape, then we want to create a new shape. Okay, and we want this shape to be to contain the same tetromino. Okay. Tetromino. So let's make it clear. We use this to refer to this object's shape. Now this object shape is assigned to this new shape's tetromino, but now the coordinates will be different. So we need to actually define the coordinates here. So when we rotate, so we just new shape, and we need to set its x and y coordinates, because now when we rotate the shape, its coordinates will change. Okay, so we haven't defined these methods, set y and set set x and set y. So I'm gonna quickly define them here. So when we want to set x value, so we're gonna pass two two input. So first would be index, because tetromino has rows and columns, right? So we can use like a row number here, and x, new x value, and and for coordinates of this of this shape, right? And we assign for specific row in the zeros column, right? Because 0 column contains x value and 1 column contains y value. So we assign x. Similarly, we set y here, but instead, so why we're doing this? When we rotate the Tetris block, we want to assign different coordinates for it. So that's why we are dealing with coordinates here. So we assign y, but instead of 0, we use 1, because as we said, 0 column contains x, and 1 column indexed 1 contains y values. And we can also define like getters here. So we can say private int get x. And we pass the row and return. What do we return? We return this coordinates in the specific row. Return value in the 0 in a column indexed with 0. And similarly for y, get y. Again, we pass the row here. Return this coordinates row, but here we return 1. Okay. So we have setters and getters set up. Let's come back to our rotate clockwise code. So when we want to set new x, and we want to iterate through each rows here. So instead of defining I can define row to make it more meaningful, right? And when we set x, we pass the row, and here we want to rotate so that when we want to use value of y to be assigned to x. Okay, so it means that we are rotating the shape clockwise. So if we have this shape and then we rotate clockwise, we will be reassigning the coordinates. Similar to what we did with x, we do with y, and we get x value from that specific row and assign it to y. Here we need to negate it because this is how we correctly rotate. So we need to negate this. Otherwise, rotation will be in return. We get different shape when we rotate. Return, and we return this new shape that we have just created. Okay. So we at least have one clockwise rotation. Now I want to just progress a little bit, and we want to also create Tetris class, right? This is where we will be creating the actual swing. We'll be using swing framework. So Tetris will be built using Java's JFrame class. So we extend the JFrame. These are implementation details. That's why I don't pay too much attention to how we actually do this. What is important is, so this tetrominos, this shape class, so we understand the internals of we understand the internals of the Tetris. We can port our code to different language if we want to. So okay, let me get back. So when we create Tetris class, so we're gonna have we actually set the size for this frame. Let's say we want to have like a rectangular shape of this board, and we define when we close the window, we want it to close completely. So we define, say, default close operation, exit on close. And this is where the frame starts. It's public. I'm gonna create a main method. And we're gonna use this my Tetris object, new Tetris, and set my Tetris to be visible to true. We want to be able to see it. Does it say expected 0 arguments? Set visible. Oh, sorry. It should be set visible. Okay. So this is the this is the box that's it starts when you start the when you start the main method, it just creates an empty window. So let me share my screen where this window is created. Okay. Just a second. Share. So this is the window that it just created. As you see, it has nothing in it. So I actually there are more steps that before we can see any block falling for the Tetris game. So I'm gonna skip towards the end of my session, towards the end of my code, and start the ready game. Okay, so I can share my code with you in dev post, so you can understand like which what exact how exactly the code looks like, because we already spent an hour and a half, an hour and 40 minutes. And for the interest of the time, I'm just going to show you the end result now. So as you see, this intermediate result doesn't have any shapes coming down. So I'm going to stop it and start the game where actually it works from my backup code. Okay. Slides, okay, share screen, window. Okay. So as you see, so I skipped many steps here, but the idea is when you rotate the shape, so as you see, the shapes start to fall down here, and can actually use key events to actually interact with the element. So all of these are done using Swing. Yes, it works perfectly because I'm running it from my backup code. I will share this code later time on dev post, but the end result will look like this. We skipped like many steps. That's why there's no, yeah, this is, it keeps like dropping the shapes like this. So we can rotate, which we implemented the method, right? So we know what it does when it rotates. So yeah, it changed the coordinates here, as you see when we rotate. So we know how it does because we've already implemented the code. And this doesn't rotate, as you see, the square, because in our code we set it to be not rotatable. Okay. So what happens after the game completed? There's a question. I mean, is there any restart option, or have we manually run it again? Yeah, we manually run it again. So we let this shape to complete. So for example, let's say we're playing the game and there are shapes falling down. And yeah, I think game ended. Yeah, no more shapes are coming down, so game ended. So we can restart the game. Just close this. Restart the game again. Okay, I'm gonna share the same screen again. Okay. Yeah, again, this is a completely new window. Again, yeah. Yeah, this is how it looks. It can we haven't implemented these keystrokes because it's specific to Java Swing. The purpose of this session was not to educate you with Java Swing framework, but to learn about a Tetris game, right? So I skipped that part. These are all implemented using Java Swing. Of course, we can implement this using on console. No problem with that. Just Java Swing was visually superior than to console. That's why I used Swing. Yeah, I will definitely share the game code and this is how it works. It has a lot of bugs. Just if you find any bugs, just I think you should be able to comment in dev post saying that, or maybe create pull requests. Yeah. So yeah, that wraps up my session. I know we skipped swing section. As I said, it wasn't a focus of today's session. It was a session to just understand how Tetris blocks are built, how they are rotated, how they are actually start to fall down from the top, and what coordinates, how we maintain their shape using coordinates. So that was the focus of today's session. I hope that was interesting, and thanks. Yeah, thanks for stopping by, and I'll see you in my next sessions. And yeah, I'm gonna end the broadcast here, and I'll see you next time. Thanks for coming to my session. Have a good day ahead.